prescribed. And that was when they decided to prescribe it for narcolepsy. Had you heard anything like that?
I thought it was in the reverse, but I'm open to hear it. And listen, the course of a lot of these drugs and how they hit market is super interesting. I've been learning more and more about this because one of my colleagues who works on aggression and mating behavior, which fascinates me, has identified some peptides that can really reduce anxiety. They put these to the pharmaceutical industry. Pharmaceutical industry wasn't interested in them at all, even though the safety margins are huge. So you say, why wouldn't they want this? Well, it turns out these same drugs failed in a schizophrenia trial a long time ago, so no one will go near it with a 10-foot pole. So the way the pharmaceutical industry generally approaches drugs is they love to remarket drugs for which there's already FDA approval, because then they don't have to go through all the safety stuff.
Right.
And when they do that, they can renew the patent. This is crucial, right? Because if you can get the generic version, now with things like GoodRx and these like little apps you can get, I mean, you can go into a pharmacy, you hit GoodRx, and it'll say, oh yeah, we've got some stuff that's about to expire. This $300 a month drug is $10. I've had this happen. It's amazing. If they can keep it out of the generic market, that's huge. And the way to do that is to find a new clinical use. So I don't know which one came first, narcolepsy or these focusing ADHD uses, or as a performance enhancer. But if the pharmaceutical industry, the people that own the patent to that drug, can find a new legitimate use, they just bought themselves, I think, another 10 years on the patent.
So this was originally prescribed for schizophrenia, and then they were going to use these peptides for mating?
Yeah. So in terms of the aggression, this is really interesting. This is the work of a guy at Caltech named David Anderson, and he works on mating and aggression and the relationship.
Human beings.
He has work related to humans, and the neighboring lab works on humans, but in mice and in humans. But these areas of the brain are really conserved. We can talk about which brain area, but what he discovered is that, meaning, that in mice and in humans, these brain structures look identical.
Okay.
And that the same classes of neurons exist, that if you were to stimulate them, because neurosurgeons have done this, people go into a rage, or in animals, if you stimulate them, the animals go into a rage. In fact, there are these videos online, they're incredible, where this is Dayu Lin's work when she was in David Anderson's lab. So you take two mice, a male mouse and a female mouse, and they're mating, right, as it were. And then they stimulate these neurons, because they can do that now using light, believe it or not. And the male immediately tries to kill the female. You can even just put him in a cage alone with a glove filled with air. He's walking around, you stimulate these neurons, and he just goes into a rage, right? Just trying to destroy this glove. But here's what's super interesting and no one understands. If you put this animal into a cage alone and stimulate, it looks pretty normal. It doesn't do anything. So it's not like it attacks itself. And every time there's this, horrible news event like the school shooting thing or something like that, I always think, like what's going on there's a certain brain area. It's called the ventromedial hypothalamus. And this is a brain area that's really interesting because it has a population of neurons that control mating. You stimulate them and animals will just start trying to copulate with basically whatever's around. If you give them a choice of their usual preference of, females if they're male, males if they're female, because that's the way mice go, one or the other, they will just try and start mating. You stimulate the other group of neurons, and they will try and kill the other mouse. So these are like switches in the hypothalamus. And
are these like very distinct? Like when we talk about like neurons and switches, like how do you distinguish between the one? Can you see them? Like what is the difference?
Great question. So for many decades, it was known that if you stimulate this brain area, you could get aggression. This is actually Nobel Prize winning work of a guy whose last name is Hess. And what they found was if you stimulate this brain area, cats would go into either two kinds of aggression. It was either defensive aggression, kind of with hair up,
right,
or you would stimulate a little bit more, and they would do the predatory aggression. Right? I'm probably doing this wrong, but like ears forward, and you're the hunter. Last time, I'm still learning about animal behavior in this way. But what's really interesting is that for years, no one could understand why, if you also stimulated this brain area and you used a different pattern of stimulation, you get mating behavior. And it turns out that the neurons are mixed in there like salt and pepper. David Anderson's lab figured out that these are molecularly distinct neurons. And what makes them distinct is really interesting. If they stimulate only the neurons that have the estrogen receptor, they become aggressive. And this again goes back to this thing that we talked about a while ago, which is that testosterone aromatized, converted into estrogen, has these incredible effects on aggression and masculinization of the brain. And a lot of people think, in fact, people heard me say that last time and said, oh, you're trying to say that estrogen is doing everything testosterone is doing. No, it's that things like testosterone and estrogen control gene expression. And so the fact that it's estrogen or testosterone, it doesn't really matter. It's the fact that these are molecularly distinct neurons. They can trigger these neurons and they can get very distinct outputs of behavior. But what's crazy is you stop stimulating, the animal just goes back to doing whatever, and then goes, oh yeah, I think I'll try and mate again. Now, eventually the female's like, hey, this is getting confusing. But it's clear that these sorts of things are also happening in humans. But normally we have kind of a weighting of aggression versus mating behavior, right? Some people choose to combine those, right? There's kind of extremes of that. Rape, there's rough sex, there's all sorts of, it's uncomfortable for people to think about that, but there's a continuum between aggressive versus approach type behaviors. And for whatever reason, this drove me to start looking at different mating behaviors of animals online. Like if you watch ferrets mating, it's like, he's biting the back of her neck. She's squealing all over the place. Like, this is uncomfortable for some people to see. Some people probably like watching this stuff. But you look at animals mating, and there's a kind of a balancing act between, what looks, it's not, you wouldn't call it lovemaking. Let's put it that. You'd call it mating that's pretty aggressive. And that's very common in the animal kingdom. So,
is it common in the animal kingdom because in order to have strong genes that pass on, you need a strong animal, and so they express themselves in this aggressive way to prove to the female that they're strong enough to mate and procreate? Like, what is the reason for that sort of aggressive? Is there a reason?
Well, it's a great question. So there's this theory called hydraulic pressure theory. This was developed by Konrad Lorenz, which is another Nobel Prize winner who studied animal behavior. And here's the idea is that all of these different populations of neurons are in the hypothalamus. This is a little tiny, tiny thing. I mean, it's the size of like a little gobstopper candy, like a little gumball. Mm-hmm. And you've got neurons for aggression, neurons for mating, neurons that turn on to make sure that animals don't try and mate with the wrong species, right? We take this for granted. Like, how come a cat doesn't try and mate with the dog? Now, the dog might hump, but that's a different thing altogether. So it's all harbored in there. And this hydraulic theory is that all of these things are kind of weighted probabilities. So there's never zero probability that any of this will happen unless they're in sleep. But maybe it's 10% aggression, 80% mating while they're mating, maybe another male